everyone. So we are picking up right where we left off in school today on Zoom, and we're doing a video for the remaining problems in the Trig Identity Day 1 notes that is posted in the assignment section. So here we go. So we left off on number 13, and number 14 is very, very similar to number 13. So we want to make sure that you guys know how to do this one. So I'm going to go over it one more time and make sure that you guys know how to do this. Okay, so we'll take a look and we realize that tan squared and we have a secant, they really don't have anything in common. So we have to bring in something that would be in common. And I happen to remember that if I look at my identity sheet, I have 1 plus tan squared x is equal to secant squared x. So if you haven't done so already, I would probably put this manipulation down on my piece of paper. All right, I want negative tan squared. So that means I had to subtract tan squared to the right-hand side. So I end up with 1 equals secant squared minus tan squared. And then I need to isolate the negative tan squared to be by itself, meaning that I need this section to be all by itself so that I can take this whole thing out and put something in its spot. Okay, so that means I had to subtract secant squared over. So 1 minus secant squared is equal to the negative tan squared. So this is a PI that we are using, a Pythagorean identity. So please make sure if you have this written down, or if you don't have written down, make sure you do have it written down now. Okay, you should have your card out while we are doing this and taking these notes. Okay, now the whole reason why we're doing this PI is so that I now can have secants in place. Okay, and I can now try to get something to cancel. So today we also talked about that this also got us into a dot situation. So if we don't remember what dots is, it stands for the difference of two squares. Okay, the difference of two squares. So that sets us up so that I can take my numerator and I can take the square root of the first term, which is 1. I can take the square root of the second term, which is secant x. Okay, so I just tear it apart. I split it up into each of 2 factors, and 1 gets a minus and 1 gets a plus. So that is the only way that I'm able to get it to cancel with anything on the denominator. Okay, I cannot cancel it the way it is right now because this one has a squared in the top, and they are not exactly the same. And then because of this minus sign, I have all this baggage. So now when I take a look at this, okay, it has to be able to cancel as an entire unit. And now I am able to get it to cancel as an entire unit because now you can see that I have 1 minus secant x that can now cancel with 1 minus secant x. And now this would be equal to 1 plus secant x. Okay, so there's our first identity that we were taking a look at today. So very similar to number 13 that we were, making sure that we get a similar identity in there so that we have the same one. Okay, using a PI to help us, it sets us up into a dot situation, which means we're factoring using 2 terms that are squares and a difference of 2 squares. And then we're able to cancel out completely as a unit. Okay, that's the only way that we're able to get something to cancel in the denominators if we cancel out both the terms. Okay, so there's going to be a U-try problem and see how you guys make out with that. All right, so next one we're going to move on to is number 15. All right, for number 15, what I want you to recognize is that we have a cotangent squared x in the first term. And in the second term, we also have a cotangent squared x. Okay, now I have a lot of students that say, oh, I could just cancel those out and I'm left with cosine squared. Okay, but that is not true. Okay, cotangent squared x is attached to cosine squared. Okay, they're buddies, they're attached at the hip. Okay, so the only way that I can, do anything to this problem is that I either need to get rid of this, meaning that I need to separate cotangent squared and cosine squared and simplify it, or I need to come up with another idea. Okay, so I can't just get rid of the cotangent squareds the way that they are. Okay, so what you should notice is that because I have a cotangent squared in the first term and in the second term, that tells me that cotangent squared x is actually a GCF, or greatest common factor, for this problem. Okay, so what that means is that I can say, oh, cotangent squared x can come out of this problem. So it can come out, and what we mean by coming out, okay, is that it gets moved to the front, and I divide every single term by that cotangent squared x. So cotangent squared divided by cotangent squared is left with 1. And then minus, if I divide this entire term by cotangent squared, okay, these cancel, and I'm left with cosine squared, okay? Now, notice that cotangent squared is still there. It's in the front because if I multiply it back into this, I get what I had originally. Okay, so all I did was take out a GCF. Okay, I factored out a greatest common factor. Now, a lot of you should notice from class today that we have a PI. Okay, we have a PI of sine squared. Okay, 1 minus cosine squared is sine squared. And then we should take a look at cotangent squared, that is also cosine squared all over sine squared, okay? And if this is over top of 1, we then realize that these two can cancel, and I have cosine squared times 1, and I'm left with just cosine squared. So that entire expression on the top is cosine squared. Now, I know some of you are going to say, yeah, but that ended up just being this cosine squared. Okay, that just is a coincidence. That's not always going to happen that way, okay, as you're going to see in the second example. Okay, so just be careful with that. It's not always going to come out to just be the way it worked out in this situation. So just know that if you have two terms, a greatest common factor in both of them, that you can't just cancel them out. Okay, you actually have to factor it out and then see where your problem goes from there. Okay, so number 16 is going to be your you try problem. I'll give that one a try. And then number 17 is just going to be a simple um, keep change rearrange or keep change flip problem. So I'm going to leave that one for you guys to do. I'm actually going to skip to number 18. Okay. So number 18 is going to be taking a look at the top here where cosecant is 1 over sine and cotangent is cosine over sine. So I'm just working in the numerator right now. And when I multiply these together, I end up with cosine all over sine squared. Okay, and then it's divided by cosine. Now remember, cosine is over top of 1, so I have a fraction over top of a fraction. So to make my life simpler, okay, we're going to keep the numerator. We're going to change this fraction bar to multiplication, and then we're going to flip or rearrange my denominator, okay, which is now going to turn into 1 over cosine x. Okay, so I'm just going to erase some of this. All right, so this is going to divide, and it's going to become 1 over cosine. Okay, so now what's going to happen is we're going to realize that the cosines can cancel, and we're going to be left with 1 over sine squared, which is then equal to, okay, 1 over sine squared. We know that the partner is cosecant, and then because it is a squared figure, we have to make sure that we keep the cosecant squared as well. Okay. So we just have to make sure we're careful here that we keep, when we do the keep change flip, that we add in the 1 and make sure that we put that in when we flip it. Okay. All right. So moving along, I'm going to do number 19, and then you guys are going to try number 20. Okay. All right. So number 19. All right. So this is one where there's a couple of different ways you could do this. Okay. For the top part, tan squared times cosecant squared. Okay. Cosecant squared is 1 over sine squared. So there's definitely a possibility with this that you could take this part right here and you could simplify it and see what that comes out to. And maybe there's a PI in there. Okay, you could also go a different direction and say, well, hey, I have one term on the bottom, so I could go ahead and break this up into 2 fractions, okay, which we talked a little bit about today in class real fast. I could turn this into 2 fractions. Okay, so I'm going to try this and just see where it takes me. Okay, so I have the same denominator. I broke it up because there's a minus sign, so it's this entire thing minus this. The tan squareds cancel. So I'm going to have cosecant squared minus 1 over tan squared. Now I could change this into sine squared over cosine squared. Keep change flip. Either way, I'm going to end up that this is cotangent squared x. And then I want to take this one step further, because if you look at your Pythagorean identities, I do have an identity that says 1 plus cotangent squared is equal to cosecant squared. So once again, guys, once you prove an identity, I would write this down on your sheet so that you don't have to keep proving this over and over again. So this says a minus. So if I take this cotangent squared and subtract it over, it's saying 1 is equal to cosecant squared x minus cotangent squared x. Okay, so that is a pi. So I'm just going to write pi here so I can follow my thinking. And this is equal to 1. Okay, so again, I would write that down on my sheet so that I don't have to keep proving that identity over and over again. Okay, all right, so you guys are going to, number 20 is going to be a U-try problem. Okay, that should be U-try number 3, and then we'll do a couple more and we'll go from there. Okay, so you guys are going to try number 20, and you guys are also going to try number 21. Okay, I would do 21 after you do number, I'm going to go through number 22. Okay. And basically that's going to just be dealing with common denominators. Okay, so if you remember common denominators in order to add fractions. Okay, so I'm going to do 22. So cosine times cotangent. There are two things being pushed together, so let's simplify them. So we have cosine times cotangent is cosine over sine. And if I put these together, all right, we end up with cosine squared all over sine. Okay, now if you're paying attention, all right, I got plus sine over 1. Okay, now please be careful. Do not cancel out the signs. Okay, we're not multiplying here, we're adding. So I can't cancel out the signs like we normally are, right? But what I can do is think about it and say, whoa, I need a common denominator. And my common denominator is going to be sine. So I multiply the bottom by sine. I multiply the top by sine. Okay, so now I have cosine squared plus sine squared all over sine. Okay, now don't get cancellation happy. I don't want to cancel these out because I just made a point of putting them together. But you should see that right here is that pi again. Okay, cosine squared plus sine squared is a pi. And hopefully you guys are saying, yes, Mrs. Hitzberger, that is 1. So 1 over sine x. And if I take this one step further, it's partner the reciprocal cosecant. And then we are done. Okay. All right. 23 is going to be for you to do. You could do one of two things. You could go for a GCF, okay, because we have a cosine and a cosine in both of those. Okay, so you could try that, which I think would probably be your easiest bet. So I'm going to say try a GCF for this one. And last but not least, I have to cover number 24. Okay, number 24 has to do with a common denominator, which I'm going to put right CD. Okay, so this, even though it's two things, they are being multiplied together, so it's all one term. Okay, and then the numerator is two things being separated by a minus sign. So this is going to be sine all over sine cosine. And then it's going to be minus cosine all over sine cosine. Okay, so again, this is what it was before it was smushed together. Okay, so now let's take a look. In the first one, it has that this is going to be 1 over cosine because the signs are going to cancel. And I'm going to be left with 1 over cosine, which is secant. minus, and then the cosines are going to cancel, which is 1 over sine, and that is cosecant. And because it's not squared, I can't go any further. Okay, it's just going to end up staying as secant minus cosecant. There's actually nothing else that we can do for this one. Okay, so it just has to stay as secant minus cosecant. Okay, and there you have it. So there's a bunch of different other cases that we've done. And as we continue to move on, I'll just keep showing you different scenarios that you could come across. And it's going to be up to you to think it through and use your brain and see what kind of different puzzles you can solve with these situations. All right, best of luck. And if you need me, reach out to me.